Hello everyone, today we are going to learn about destructors and base classes, normal versus virtual, a deep dive into C++ polymorphism and memory management. Agenda: understanding the why and how. Today, we will navigate the critical distinction between normal and virtual destructors in C++ base classes, ensuring robust memory management in object-oriented design. 1. The basics. Defining what a destructor is and its fundamental role in object lifecycle. 2. The challenge. Identifying the major pitfall of using normal destructors in polymorphic hierarchies, resource leaks. 3. The solution. Introducing the virtual destructor and how it solves the resource management problem. 4. Practical application. Reviewing code examples and established best practices for modern C++ development. The basics. What is a destructor? A destructor is a special member function of a class that is executed when an object of that class is destroyed. Its primary role is to perform cleanup operations. Purpose of cleanup. It's responsible for freeing up resources that the object may have acquired during its lifetime, especially dynamically allocated memory, file handles, or network connections. Naming convention. A destructor function is always prefixed with a tilde symbol, followed by the class name, e.g., my class. It takes no arguments and returns no value. Execution timing. For stack allocated objects, the destructor is normal destructors, the default behavior. In a standard, non-polymorphic class, a normal, non-virtual destructor works perfectly fine. However, in inheritance hierarchies, it strictly follows the static type of the pointer used for deletion. Strict type adherence if a derived class object is deleted using a pointer to the base class, and the base class destructor is not virtual, only the base class destructor will execute. The derived class's destructor is completely bypassed. The problem: resource leaks with polymorphism. Base pointer usage. We often use base class pointers. Base asterisk ptr equals new derived. Winky face to achieve runtime flexibility. Undefined behavior. UB. Derived cleanup skipped if the base destructor is normal. The derived destructor is not invoked when called. Derived resources unfreed. Any memory or resource dynamically allocated within the derived class remains unfreed, leading to a memory leak. This scenario is a classic source of hard-to-debug memory leaks in large C++ applications, diminishing application stability and performance over time. Introducing virtual destructors, the solution to resolve the polymorphic deletion problem. C++ provides the virtual destructor, achieving correct deletion by declaring the base class destructor as virtual. We enable runtime polymorphism for object destruction. When delete is called on a base class pointer, the compiler uses the pointers table. The table directs the execution flow to the correct, most derived destructor. First, execution then proceeds upward, calling all destructors in the inheritance chain. Derived, then base. This ensures all resources, both in the derived and base classes, are correctly released. How virtual destructors work. Under the hood, virtual functions, including the virtual destructor, rely on the virtual table, a core mechanism of C++ polymorphism. When a class has any virtual function, including a virtual destructor, the compiler adds a hidden pointer called the vptr, virtual pointer, to every object of that class. The vptr points to the table. The table is an array of function pointers that stores the address. Code examples demonstrating the difference. Observing the output of these two scenarios clarifies the importance of the virtual keyword. Scenario A. Non-virtual destructor. When to use virtual destructors. Best practices rule of thumb: if a class is intended to be used as a base class, and you plan to key takeaways and Q&A. Non-virtual destructors. Only call the destructor of the static type. Leads to memory leaks when deleting a derived object via base pointer. Virtual destructors.